welcome to Quant Questions Week 20. This week we'll be looking at questions from triangles. Let's get to it. In the given figure, PQ is parallel to ST. This line is parallel to this line, and TV is parallel to RS. This line is parallel to this line, and TU is perpendicular to ST. So if TU is perpendicular to ST, this is 65, this 25, this will be 65. So in order to progress further, first thing we do is we should draw a line parallel to ST passing through R. Let's label this line AB. Look at QRA and RQP. Can you see they are alternate interior angles? AB is parallel to QP and ST. So QRA is alternate exterior angle for RQP. So QRA will be 70 degree. Similarly, look at RST and VTS. This 65 degree and this 65 degree will also be alternate interior angles between two parallel lines. So if this is 65, now look at ARS and RST. ARS and RST. This will also be 65 degree. So QRS altogether will be 135 degree. And that will be the answer. Next, in the figure, not drawn to scale, given below, is in the figure, not drawn to scale, given below, please appoint an AB such that AP is to PP is 4 is to 3. This length, sorry. This length is 4x, this length is 4y. Oh, sorry, 3x. PQ is parallel to AC. This line is parallel to this line. And AC and QD is parallel to CP. AC and QD. Sorry, QD is parallel to CP. QD is parallel to CP. Okay. In triangle ARC, I think this P should be R. A triangle ARC, angle ARC is 90 degree. This is 90 degree. And in triangle PQS, PSQ, also 90 degree. This is also 90 degree. Length of QS is 6. Length of QS is 6. This is 6. What is the ratio of AP is to PD? AP is to PD. Okay. Let's work. Right now I can see, given that QP is parallel to AC, I can go on to say CQ is to QB will also be in the ratio 4K is to 3K. CQ by QB will also be in the ratio. Look at BCA, this triangle. QP is parallel to the base. So the ratio in which one side is broken up is the same ratio in which the other side will be broken up. This is done. And now look at triangle BCP. Look at triangle BCP. QD is parallel to the base CP. For triangle BCP, QD is parallel to CP, which will then give us the information that DB will be 3y and PD will be 4y. Again, CQ is to QB is 4 is to 3. So PD is to DB will also be 4 is to 3. Which means our 3x is same as 7y. 3x is same as 7y, or x by y will be equal to 7 by 3. Now finally, we need the ratio of AP is to PD. AP we know to be 4x. PD we know to be 4y. So I can replace this x by y with 7 by 3. So it will turn to 7 by 3. And finally, this is the ratio of AP is to PD. 4 and 4 will get cancelled. X by y is the final ratio left. So 7 by 3, option C will be the right answer for this question. Okay, next one now. In the given figure, ABCD is a rectangle. Fine. Point P, Q, and R divide CD in 4 equal parts. So this side BC is divided into 4 equal parts, and the points S and T divide AB into 3 equal parts. Okay. So if I take one side, it can be divided into 4 equal parts, can be divided into 3 equal parts. I'm saying this side is 3, 3, 3, and 3. And here AS, ST, and DB are all 4. Okay. Find the ratio of areas of triangle PQX and STX. Ratio of this triangle, area of this triangle to area of this triangle. Now see wonderful thing. We know these are parallel lines because this is a rectangle. This angle is same as this angle. This angle is same as this angle. And let's call this angle is same as this angle. So these two triangles are definitely similar. These two triangles are definitely similar. So the ratio of their area will be square of ratio of their sides. The side is 3 units, side is 4 units. So ratio of area for PQX by STX will be 3 by 4 whole square, or it will be 9 by 16, or option B will be the answer. Okay. Next, if sides of a triangle are in the ratio 2:3:4, what is the ratio of the corresponding altitudes? See, wonderful thing, area is going to be equal to half into altitude 1 into side 1. And because this is the same triangle, area is going to be same everywhere. Can I say H1 is equal to 2 by S1? H2 is equal to 2 by S2, and H3 is equal to 2 by S3 from this. So if I need the ratio of the altitudes, it is going to be 2 by S1 is to 2 by S2 is to 2 by S3. And we should take away this 2 to 2 will get cancelled. This is the ratio of the altitudes. This is the ratio of the altitudes. What you can take away from this question is, if the ratio of sides is A is to B is to C, ratio of altitudes is 1 by A is to 1 by B is to 1 by C. Directly you can come to that. So I can break it down as 1 is to 2 by 1 is to 3 is to 1 by 4. Now I can simplify this as 2, 3, 4. So 12 will be the LCM. So 12 by 2 is 6. 12 by 3 is 4, and 12 by 4 is 3. The ratio of altitudes would be 6:4:3. Now this seems like none of the options match. Answer should be none of these. But pay careful attention. These options, this is also a common trope among question setters, how they end up taking this. Look at this second option. The first number is integral, second number is fractional, third number is integral. Let us multiply 3 everywhere. See, this will convert to the same ratio. What we wanted. So the answer to this question is not none of these. The answer of this question is option B. 2:4 by 3 is to 1. Okay. Next one then. Triangle ABC, DEF are midpoints of BC, CA, and AB respectively. Find the ratio of the area quadrilateral DEAF and the area of quadrilateral CEFE. Okay, let's work. First, this is a triangle ABC. DEF are midpoints of this is D. E. Midpoint of CA. This is E. F. This is the midpoint here. Find the ratio of area of quadrilateral DEAF. Yeah. DEAF. These will be parallel because they are midpoints. By the midpoint theorem, this will be half the length of AC and parallel to it and everything. And area of quadrilaterals, CEFE. Now see a simple idea I want to introduce that you should be aware of is known as deformation. deformation states, as long as you're not violating any rule of geometry and you're not violating any condition given in the question, you can always reimagine a simpler diagram, or you can work with simpler terms for question. We use the deformation idea very, very commonly when it comes to arithmetic. Whenever we are doing let the CP be 100, whenever we are doing let the age of somebody be 20, whenever we are assigning numbers where it should be a variable, we are using the idea of deformation. We are reimagining the question, or we are reinterpreting the question to make the task easier for us. Similarly here, I can make this task easier by imagining ABC to be an equilateral triangle. If ABC is an equilateral triangle, these lines joining the midpoints will divide the triangle into 4 equal parts, 4 small triangles of equal area, which will then give us, if each of these have area of 1. Now look at area of quadrilateral DEAF, it is 2. Then area of quadrilateral CBFE, it is 3. And therefore the answer to the question is 2:3. Enabled by simply assuming the area of each of these triangles, simply by assuming that this is an equilateral triangle. Now, even if it was not an equilateral triangle, you can go ahead and solve it, no problem at all. Can you see, if I take the area of ABC, taking area of ABC as 4x, area of ABC as 4x, can you see FE will be half the length of BC? FE will be half the length of BC. So if this length is, let's say, 2A, this length will be A. Similarly, if this length is 2C, AF will be C. Or if this length is 2D, this length is B. So for the large triangle ABC, I have 3 lengths as 2A, 2B, and 2C. And for the small triangle AB, for the small triangle, this one, AFE, the length will be how much? A, B, and C. Because the sides, ratio of sides is 1:2, the ratio of area will be 1:4. I had assumed the area of ABC to be 4x, so the area here will be x. Now, do the same processing for the other places. FP will be C, BD will be A, these are midpoints, and FD by midpoint theorem with AC, FD by midpoint theorem with AC will also be B. Now, for triangle AFE, the sides were A, B, and C, and area was x. So for triangle BFD, where sides are A, B, and C, area will also be x. By the same metric, let's look at EC will be B, DA will be A, and ED will be half of AB, which is C. So area here will also be x. And now look at FED. The 3 sides are A, B, and C. Again, the area will be x. And now perhaps you can come to your conclusion of the ratio of area of DEAF to CBFE is 2:3. But then you did not really need to do that. As soon as you assumed it to be an equilateral triangle, this processing would have become much easier. Hopefully, we also know for equilateral triangle, breaking down a shape when I join the midpoints, or if I am, let's say, working with an equilateral triangle where I am trisecting every side. Each side is divided to 3 equal parts. Now here, by joining these lines, it will get divided to 9 small equilateral triangles. 1 from here, 3 from here, 5 from here. In every row, you see 1, 3, and 5. Here you're getting 1 and 3, so 4. So breaking down an equilateral triangle into an odd perfect square number of small triangles is always possible. Okay. Next question. In triangle ABC, AC is equal to 6, BC is equal to 8, and AC is equal to 10. 6, 8, and 10. Okay. A perpendicular dropped from A, B, C. So this is 6, this is 8, this is 10. all of us are hopefully geared up enough to realize this will be a right angle triangle. It's not something that is surprising or shocking to us. A perpendicular drop from B meets side AC at D. Let's say this is the perpendicular from B dropped at D. Now, the length of this perpendicular is very easily identifiable. The length of this perpendicular will be, that is, half into AB into BC. Area of the triangle will be equal to half into AC into BD. We know half and half will get cancelled. AB, BC gives me 48, AC gives me 10. So BD will be equal to 4.8. By lots of practice, by lots of vigorous practice, my expectation is 3, 4, 5, and the altitude being 2.4 here. These numbers are pretty much embedded in our head. By lots of practice, I'm guessing these numbers are already embedded in our head. But even if they are not embedded, we can of course arrive at length of BD. A circle with radius BD with center B is drawn. So this is the center. Go like this. Okay. If the circle cuts AB and BC at P and Q respectively. This is at P, this is at Q. Find then AP is to QC is equal. Now see, the radius is 4.8. So BP will also be 4.8. So AP will be 1.2. Similarly, radius is 4.8. So BQ will be 4.8. So QC will be 8 minus 4.8 or 3.2. So finally, if I need ratio of AP is to QC, I need the ratio 12 is to 32. If I cancel off 4s, I will get 3 is to 8, or option D will be the right answer. Okay. This is a simple one. An isosceles right angle triangle has an area of 800 centimeters square. What is the length of its hypotenuse? Now, for an isosceles right angle triangle, the three sides are in this ratio. A, and A root 2. Area of this triangle is given by half A square. Half A square is told to us as 800. So A square is 1600, which means A is 40. If A is 40, the hypotenuse will be 40 root 2, or option A is the right answer. Okay. Next. One of the sides of a triangle with area 80 square centimeter is 3 times the side of another triangle with area 200 square centimeter. Pay attention, this is slightly puzzling. The smaller area triangle has the longer side. So, for this triangle, for the smaller triangle, can I say half into altitude here? Finally, we need the ratio of the corresponding altitudes. Half into H1 into 3 times the side is equal to 80. And for the other triangle, it is half into H2 into S is equal to 200. I finally only need H1 by H2. I need the ratio of H1 by H2. So I can divide these two portions. Half and half will go away. S and S will go away. 80 will become 2. This will become 5. 3 will come to the bottom. Or finally, I'll get H1 by H2 be by 15. Or option A is the right answer then. Okay. Next. Dave is teaching his son geometry. He tells his son that all angles in a given triangle have integral values. Okay. All angles in the triangle are integral. He also tells Peter that 7 times the measure of the largest equals 12 times the measure of the smallest. So there are 3 angles then. There is the largest. There is the middling. There is the smallest. A asks, oh sorry, and we are told, let's say this is L, this is M, this is S. 7L is equal to 12S, but L by S is equal to 12 by 7. So I can replace it with 12K and 7K. This middling angle continues to remain M. Dave then asks Peter to find the measure of the second largest angle in the triangle. We're supposed to figure out the value of this middling value. If Peter were to guess correctly, what would be his answer? Basically, find out the middle angle. Now, there are two ways of doing it. One is pure algebra, and the other one is a little bit of brute force. Pure algebra wise, hopefully you can see this middling angle can be 7K, can be 7. Can it be 7K? No, it has to be more than 7K. It has to be more than 7K. So can I say, if it were 7K, we would not reach 180. If the middling angle were 7K, would not reach 180, or 12 plus 7 plus 7, 26K is less than 180, or K is less than 6 point something something. The other end of the extreme is this middling angle has to be less than 12K because this is the middling angle. So if it was equal to the largest angle, their summation should exceed 180 degree. So 12 plus 12 plus 7K, or 31K is greater than 180, or K is greater than 5 point something something. We knew all the angles were integers. Which is to say, if K has to be less than 6.66, 6 point something something, and greater than 5 point something something, the only acceptable value that K can take is 6. If the only acceptable value that K can take is 6, this will be 72, this will be 42, and if these two add up, they give me 114. So the middle angle will be 66. And now we know the answer, what Peter would mark. This is the algebraic way of arriving at the answer. Now, the more, let's say, brute force way of arriving at the answer would be the following. Let me just copy this. We get here. Rid of these. Now see, L, M, and S. Can I say this will be 180 minus 19K? 180 minus 19K. These will be the three angles. So I know K can be equal to 1. So this will be 12. This will be 7. 19, 1 from 180 gets me to 161. I will stop, or I will find an acceptable case when the first number is greater than the second number is greater than the third number. This is not there because L is smaller than M. So I go for K equal to 2. I get 24. I get 14. 180 minus 38 will get me to 142. At K equal to 3, it will be 36, 21, and 123. At K equal to 4, it will be 48, 28, and 104. Still not great. At K equal to 5, this will be 60, this will be 35, this will be 85. Still not great. At K equal to 6, this will be 72, this will be 66, and this will be 42. And yes, all conditions are satisfied here. The first angle is indeed the largest, the second angle is indeed the middle one, and the smallest angle is indeed 42. But that does not guarantee that this is the only case possible. Maybe there are other cases. Although, given this is a theta question, there has to be only one case. But maybe there are other cases. So let's check for that also. If we get to K equal to 7, this will turn to 84, this will turn to 49, and this will turn to 47. And this becomes an unacceptable case because remember, the smallest angle is now becoming greater than the middling one. So prior to this, all of these are unacceptable cases. After this, all the cases are going to be unacceptable because the smaller angle will be greater than the middle angle, which now tells us there is only one acceptable case. And in this case, what is the second largest angle? Second largest angle is indeed 66. Choose the algebraic way of solving or the brute force way of solving. Either of them are fine. Okay. Next, a triangle ABC. Also fairly straightforward question. ABC. AB is extended to D. BC is extended to E. And CA is extended to F. CBD This is 110 degree. So this will be 70 degree. And ACE is 130 degree. This is 130 degree. So this will be 50 degree. Now, if this is 70, this is 60. This is 70, this is 50. This will be 60 degree. Then you can come to 120, or you can use the external angle theorem. 70 plus 50 gets you to 120, or you can get to this outcome, right? From this 110. From this 110, we were able to identify this is 70. So from this 130, you can see it is 70 plus this angle adds up to 130. So this angle will be 60, which gets us to the external angle here as 120. Either way, the measure of angle FAB will of course be 120. Okay. Next, if the sum of supplement of an angle and complement of the same angle is 162, then find the angle. Supplement of an angle is 180 minus x. Complement of an angle is 90 minus x. This is equal to 162. 270 minus 2x is 162, or 2x is equal to 108, or x is equal to 54. Option B, simple. Next, a ladder of length 26 feet is leaning against a straight pole such that the lower end is 24 feet from the base of it. This is 26. This is 24. Now, familiarity with Pythagorean triplets is something that you cannot afford to miss. Familiarity with Pythagorean triplets is extremely, extremely important. So 26, 24, the third side should instantly come to you 10. This is the 5, 12, 13 Pythagorean triplet. Now, if the upper end slides up 2 feet against the pole. So now we are at this situation. See, this is still 26. Previously, it was at a height of 10. Now it is at a height of 12. By approximately what distance will it move towards the pole if the upper end slides up 2 feet against the pole? So we have to figure out this length, and we have to figure out the difference. Whatever length we get here, difference between 24 and L. Okay. L will be given by, L square will be given by 26 square minus 12 square. So L square will be 676 minus 144, or L square will be 532. Now, clue given in the question is by approximately what distance, round off your answer. Essentially, they're telling us we are not going to get a perfect, we are not going to get a natural number here. But can you see 532 is very, very close to 23 square. So, our L will almost be equal to 23. Our L will almost be equal to 23. Or it will be 23.01, 23.02. That precise degree of accuracy is not really needed, because the question itself tells us enough, gives us enough clue that you will not reach that precise degree of accuracy. Surrounding of your answer or using approximately to tell us this L is now 23. Now the final question is, by approximately what distance will it move towards the pole? Previously it was 24 feet away, now it is 23 feet away. So it has moved towards the pole by 1 feet. It has moved towards the pole by 1 feet. Answer will be 1. Okay. Next, there is a square field of 500, square field of side 500-meter long each. Okay. It has a compound wall along its perimeter. At one of its corner, triangular area of the field is to be cordoned off by erecting a straight line fence. The compound wall and the wall fence will form its borders. Okay. If the length of the fence is 100 meters, what is the maximum area that can be cordoned off? This is 100. Now, this is 100. This is A. This is B. This is A. This is B. This is 90 degree. Now, the hypotenuse of this triangle is 100. I need maximum value of half AB. Maximum area is needed, half AB. Also, I know A square plus B square is equal to 100,000. 100,000. Now, here, what you can potentially use is concept from algebra called substitutability. If I change A with B here, this expression does not change. This expression does not change. And therefore, the one extrema will lie when both of them are equal. The other extrema will lie when one of them is everything and the other one is absolutely zero. Can you see if one of them is absolutely zero, this product of half AB will necessarily be zero. If one of them is zero, then the product of half AB will necessarily be zero, and we don't want this product to be minimized. So the extrema that is occurring will necessarily be maximized when A is equal to B. If A is equal to B, we get 2A square is equal to 5,000, or A square, sorry, equal to 10,000, or A square is equal to 50 root 2, or A is equal to 50 root 2. If A is 50 root 2, area will be given by half into 50 root 2 into 50 root 2. Cancel this with 2, 50 into 50. The area will be 2,500 square meters. Area will be 2,500 square meters. Although this is geometry, maxima, minima principle is getting used. Now see, if you've done enough geometry questions, you would know if the hypotenuse is given, the maximum area is when you take it in a isosceles right angle triangle. But then in case you don't know it, you can reach that conclusion via algebra as well. Okay. Next, which of the following is the measure of the angles at the point of intersection of diagonals of a rectangle of dimension 5 root 3 by 5 centimeter? Okay. If this is 5 and this is 5 root 3, look at this diagonal. First diagonal I'm going to drawing. This is a right angle triangle. If this is 5, this is 5 root 3. This diagonal will be 10, no problem at all. But the ratio of length of side is 1 is to root 3 is to 2, which means opposite one you have 30 degrees. Opposite 5 root 3, you have 60 degrees. Similarly, if I draw this diagonal, this is 5 root 3. This will be 30 degree again. This will be 60 degree again. This entire angle is 90. Now, look at this. This is 30 degree. This will also be 60 degree. So now, if you look at this triangle, the triangle in which the pointy end is sort of horizontal, this angle here is 60 degree. Or if you look at the triangle in which the pointing end is pointing towards the bottom, this is 30, this 30. This angle here will be 120 degree. This angle here will be 120 degree. So now, when we are asking which of the following is the measure of angles at the point of intersection of diagonals of rectangle of dimension 5 root 3 by 5 centimeter, both these answers are acceptable. Both these answers are acceptable. But the question is asking which of the following. So then we will mark option B. Because of the following, 120 is an acceptable answer. If they had asked what is the measure of the angle at the point of intersection of diagonals of a rectangle, then the answer would be cannot be determined. But which of the following is the measure of the angles at the point of intersection? 60 is also acceptable, 120 is also acceptable, 120 is present in the options. That will be the right answer. Okay, next. In triangle DEF, the sides DE and DF are 7 and 12 respectively. Okay. This is D, this is E, this is F, this is 7, this is 12. What is the length of side EF if angle FDE is 60 degree? Now, you can do it by using area and Heron's formula. If you take this as X, you take this side as X, semi-perimeter will be 21 plus X by 2. So area of this triangle will be given by half into 7 into 12 into sine 60, which is root 3 by 2. will be equal to under root of 21 plus x by 2 into 21 plus x by 2 minus 12. Sorry, how is it 21? It should be 19, no? Should be 19. It should also be 19. So 19 plus x minus 12 will give us 5. So x minus 5 by 2. Then this minus 7 will give us 14. So x plus 5 by 2. And then it will also give us how much? 19 plus x by 2 minus. So 19 minus x by 2. So I can get rid of this half. I can get rid of this 2 and get rid of these 4 2's on this side because they're under root. 2 2's are needed from here. So now you will have 84 square into 3 is equal to 361 minus x square and x square minus 25. Now you can take x as t and do your subsequent solving. And it is going to be difficult. It is going to be difficult because eventually you are going to reach an equation in which the roots are going to be 109 and 277, both of which are prime numbers. It is going to be difficult. The alternate way of doing this is using the cosine rule, where you will have cos 60 degrees is equal to the two adjacent sides square, 7 square plus 12 square minus x square by 2 into 7 into 12. This will be the simplest one. And cos 60 also we know to be half. Get rid of this 2 and 2 1. So we have 84 is equal to 49 plus 144 minus x square. X square can come here. I'll get minus 35 from this is equal to 109 or x will be equal to under root 109. Why I've shown the earlier path is, yes, a path to solving exists here, but if we use the cosine rule, the path to solving is much, much simpler and you wouldn't have to go down that, you wouldn't have to do as much work. The path to solving will be much, much simpler. Okay. Next. In triangle ABC, D is a point on BC such that BD is to DC is 2 is to 3. The area of triangle ABD is 54 centimeters square. Then find the area of ABC. I have A, B, and C. And D is given such a way. This is 2x. This is 3x. Now see, area of ABD. Forget whatever is given here first. Area of ABD and ADC. The altitude is identical in both these cases. The only way the area is different is because of the bases. So if the bases are cut in the ratio 2 is to 3, their area will also be in the ratio 2 is to 3. So if this is 54, which is 27 into 2, this will be 81, which is 27 into 3. Or the area of the entire triangle will be 27 into 5. Or the answer to this question will be option B, 125. Okay. Next. Area of an equilateral triangle decreases by 8 root 3 centimeters square if the side is reduced by 4 centimeters. Find the length of the side. Okay. Area of an equilateral triangle is given by root 3 by 4 a square minus root 3 by 4 a minus 2 4 square. This is told to us as 8 root 3. It's wonderful. I can get rid of root 3 straight away. Then this 4 goes here. I'll have a square minus a minus 2 whole square. So I will have a minus a plus 2 and 2a minus 2 is equal to 42. So I'll have 4 times of a minus 1. Sorry, I have made a mistake. It's not a minus 2, this will be a minus 4. So that will change the complexion of the game entirely. Will become 4 This will become 4. This here. That 4 times of 2a minus 4 is equal to 32. So cancel becomes 8. So 2a will be equal to 12 or a will be equal to 6. The length of the equilateral triangle or side of the equilateral triangle will be 6 centimeter in this instance. Okay. Next, in the given figure, triangle ABC is an equilateral triangle and DCE such that AB is bisected by this DCE lines bisect AB. For an equilateral triangle, the wonderful thing is the angle bisector, the perpendicular bisector, the median, the altitude, all of them are the same line. So C is everything. So this is 90 degree, this is 30 degree, this is 30 degree. These two lengths are equal, everything. Now, if AC is equal to CD, if AC is equal to CD, this length is equal to this length. Find the measure of CAD. Now, if this is 30 degree, this here will be 150 degree because it is on a straight line. Now, if these two angles are identical, this is X and this is X, these are identical and they add up to 30. Both of these angles will be 15 degrees each. This is what the question demanded, CAD. So answer to the question will be option B, 15 degrees. Next, in triangle PQR, angle P is 30 degrees. Okay. PQR, this is 30 degrees. The length of PQ and PR are 10 and 16. This is 10, this is 16. Let L and M be points on PQ, PR, such that LM is parallel to QR. LM is parallel to QR. Okay. PL is 5. See, if PL is 5, this is L, this is M. PL is effectively half the length of PQ. So this will also be 5. And PM will be 8 and MR will be 8. These sides are getting bisected, or LM's length, if the length of QR is 2x, length of LM will be x. Length of LM will be x. Okay. Which is now to say the dimensions of triangle PLM, are exactly half the dimensions of triangle PQR. The dimensions of triangle PLM are exactly half the dimensions of triangle PQR. So the ratio of their area will be 1:4. So if we find out the area of PQR, which will be given by half into 10 into 16 into 1/2. Sine 30 is 1/2. We can get to 40. And area of TLM will be 1/4 of that. So the area here, here will be 10. For the full triangle will be 40. So area of the quadrilateral LMQR. LMQR will be 30. Answer we can mark as 30. Now we can arrive. See, this is similarity based understanding. You can also come to the same conclusion using basic formula for area. Area for PQR will be half into 10 into 16 into sine 30. And area for TLM will be, if from the total area of the triangle I remove area of TLM, I will get the area of LMRQ, this quadrilateral. So half into 5 into 8 into sine 30. So sine 30 is half. I can take it out common. I can take half out common. I can take 5 out common, 8 out common. I'll be left with half into sine 30 into 5 into 8, 4 minus 1. This is what I'll be left with. A 2 extra from here, a 2 extra from here. So this cancels with this to give me 2. Sorry, 4. This sine 30 also cancels with this 4 to give me 2. So I'm finally left with 5 into 2 into 3. For the area needed is 30. For the correct answer remains 3. You can arrive it via this long description or long expression, or you can directly see if the middle line is the top triangle form, the top head portion form. That is basically 1/4 the area of the original triangle. Okay, next, let PQR be an equilateral triangle. Therefore, I absolutely love equilateral triangles. PQR. Let S be a point on side QR such that QS is to SR is 1:3. So if this is X, this is 3X. If side of the triangle is A, find the length of PS. Okay. This is A. I need the length of PS. Now we can go about doing it two ways. We know because it's an equilateral triangle, and I'm getting rid of this X and 3X, I'm calling it A by 4 and 3A by 4. One way is using the cosine rule that we already know. So it will be S cos 60 half equal to A square plus A square by 16 minus PS square by 2 into A by 4. This cancels with this. Two. This 2 will go to the top. Let me not cancel this 2 with anything. Let me do this. Let me cancel this 2 with this 2. A square goes to the top. Or this entire thing. A square by 4 comes here. I'm left with 17 A square by 16 minus PS square. PS square, if I bring over here, I'll be left with 13 A square by 4, or PS will be equal to A by 4. This will not be 13 A square by 4. This will be 13 A square by 16. Root 13, which is given to us in option B. So this will be the answer. An alternate way of handling this, would be by dropping a perpendicular from P to the midpoint here. By dropping a perpendicular P to the midpoint, let's call this M. Now PM, length of PM. The altitude in an equilateral triangle is given by root 3 by 2A. Root 3 by 2A. SM will again be A by 4. So PS square will be equal to root 3 by 2A whole square plus A square by 16. So this gives us how much? A square will be equal to 3A square by 4 plus A square by 16, or A square is equal to 13A square by 16. PS is equal to A by 4 root 13, which is again given to us in option. You can do it by dropping a perpendicular, or you can do it by using the cosine rule that we know from earlier. Okay. Next, in right angle triangle PQR, right angle beta R, PQ is 12. Okay. This is P, this is Q, this is R, this is 90 degree, and this is 12. Let S and T be the midpoints of PR and R. This is S, this is T. Find the sum of squares of lengths of TT and QS. Easily done. Let's say RQ was 2A, PR was 2B. Because it's a right angle triangle, 4a square plus 4b square is equal to 144 square of p cube. Now, can I say qs square? Qs square will be equal to b square plus 4a square is equal to qs square. And for pt square, it is a square plus 4b square. This is equal to pt square. Finally, what we were expecting to find was sum of squares of lengths of pt and qs. So if I add it up, I will get 5a square plus 5b square is what we are seeking. This is equal to qs square plus pt square. So finally, we'll have, see, 4a square plus 4b square is 144, gives us a square plus b square is equal to 36. So I can cancel off 4s everywhere. So 5 into 36 or 180 will be our final answer. Option B we will mark. Next, in triangle ABC, angle C is 70, angle A is 30. A, B, C. This is 70. This is 30. So this will be 80. Let D and E be points on BC and AC respectively. Oh, I should make a bigger diagram. Those points are being involved. So make a bigger diagram. A is 30. This is 80. This is A. This is B. This is C. D and AB points on BC and AC respectively, such that AD, this is D, AD is equal to AB. Okay. If this is equal to this length, if this is 80 degree, this will also be 80 degree, which will mean this is 20 degree. Which will mean this is 20 degree. Which will mean this here will be 10 degree. Now E was a point somewhere here. E points on BC and AC. E is some point here. Where is it? Is it here? Is it up? I don't know. But the EAD will definitely be 10 degree. Answer to the question is option A, 10 degree. Next, find the area of the largest triangle which has two of its sides, 5 centimeter and 12 centimeter, and all three interior angles are acute. Okay, the wording of the question is not correct. The wording of the question is not correct. Let me edit the wording. 1 minute. Okay, I've edited the wording. Previously, the wording was not correct. You will get the correct wording in the PDF, of course. Which of the following can be the area of the triangle which has two of its sides as 5 centimeter and 12 centimeter, and all three interior angles are acute? Okay. Now see, area of a triangle will necessarily be, for this triangle, it will be half into 5 into 12 into sine theta. This triangle, this is 5, this is 12, this is theta. Area will be half into 5 into 12 into sine theta. And do we know anything about the sine theta? We know sine theta will be less than 1. Will be less than 1. Why will it be less than 1? Because all the three interior angles are acute. If the interior angles had not been acute, if one of them had been 90 degrees, then the maximum possible value of sine theta 1 could have been achieved if this interior angle was 90. But because all three interior angles are acute, I know sine theta has to be less than 1, which means 30 into something less than 1 is happening. 30 into something less than 1 is happening. So which of the following can be the area of the triangle which is having two of its sides as 5 and 12 and all three interior angles are acute? It has to be the area which is less than 30. So answer can be option A. These three are greater than 30 and therefore are ruled out. Okay. This is a tricky one. In the given figure, AF is to FP is 3. This is 3x. This is 2x. AE is to EC is 4:1. This is 4y. This is y. AD is the median of BC. AD is the median of BC. So this length equal to this length. Cool. Find the ratio of FO is to OE. Find the ratio of FO is to OE. Now, in order to solve this, we need to pay attention to lots of stuff. We need to pay attention to lots of stuff. See, if I join these spots, F to D, I join E to D. Look at the triangles. Look at these two triangles. Can you see the bases are in the ratio 2:3? The bases are in the ratio 2:3, and the altitude is to the same length. So area of AFD by FDD area will be in the ratio 3/2. Similarly, let's look at this area of EEC, area of this AED and DEC. Hopefully, we can reach this conclusion also. Area of AED by area of AED, area of EDC will also be equal to 4/1 because the altitude is the same. It is only the ratio of the bases. Now, because D is the midpoint, because D is the median, can I say ABD and ADC have identical area? The bases are also identical. The altitude is also same. So, if I go ahead to describe, as in define the area, here let the area be 2K. The area here will be 3K. So area of ABD right now is 5K. So area of ADC should also be 5K, which means the area here for AD will be 4K and area for DC will be K only. This much is known. This much is known. This is absolutely wonderful. This is absolutely wonderful. Okay. Now, let's look at now this is where the tricky part comes in. This is where the tricky part comes in. You need to understand. Look at AFO. Look at AFO. Finally, we need the ratio of FO is to OE, no? AFO and AOE. AOE. Area of AFO by area of AOE will be in the same ratio as area of FOD by area of ODE. See, for the first two, the base is FO and OE, the altitude is the same. For the second set of triangles, the base is FO and OE, the altitude is OD, or the altitude is the same. It is not necessarily OD, but the altitude is this. Altitude is going to be identical. So these two ratios are identical. If these two ratios are identical, by using rules of ratio manipulation, by using ratio, I don't know what is that component or dividend to. Can I say area of AFO plus FOD? This ratio will be equal to area of FOD plus AFO by area of AOE and ODE. And do we know this ratio? Area of FOD and area of AFO, these two add up to give me 3K. area of AOE and AOD add up to give me 4K. So the ratio here is 3 by 4. Now work your magic backwards. This 3 by 4 is also true for this first ratio or the second ratio. Now area of AFO and AOE is in the ratio 3:4. For them, the only thing that is separate, the only thing that is different is the base. The altitude is the same. The only thing that is separate is the base. How are they getting different areas? Because this from here it implies FO by OE has to be in the ratio 3 by 4, or the answer to the question is option C. Or the answer to the question is option C. It is a very, very fun question. It does not ask you to solve so much as break down figures and look at ratios and then get your eventual answer. Okay, then this last one. What is the maximum area in square centimeter of an equilateral triangle inscribed inside a square of area 4 square centimeter? Okay. Let us say we have a square drawn. Now, if I'm trying to draw an equilateral triangle, it will go the largest equilateral triangle that can be drawn within a square will go something like this. Here and here and here. See how this works. If this is side 4, this is A, this is A, this is 4, this is 4 minus A, this is 4 minus A. This length is under root 4 square plus A square. This length is under root 4 square plus A square. And this length is 4 minus A root, whole thing multiplied by root. And they have to be identical. So first we have to figure out the measure of A. First, we have to figure out the measure of A. So, can I say A square plus, oh, I have made a mistake. The side is not A, the side is 2 because area is 4. Okay. The side of the square will be 2. So, this will be 2, this will be 2, this will be 2, and this will be 2. So, I will now have A square plus 4 is equal to 2 minus A whole square into 2. So 2 into 4 plus A square minus 4A. Which gives us A square plus 4 is equal to 8 plus 2A square minus 8A. A square plus 4, A square plus 1. I'm left with A square minus 8A plus 4 is equal to 0. We've reached here. Now, we can get to a measure of A using Sridharacharya formulation. A will be equal to 8 plus minus under root A square. 64 minus 16, so 48, which is 4 root 3. I'm directly writing 4 root 3. I will write the full thing. 64 minus 16 whole thing divided by 2, which will be 8 plus minus 4 root 3 divided by 2, which will become 4 plus minus 2 root 3. Now you would have to be a little cognizant. If the side of the square is 2, the length, this small length A, cannot be greater than 2. So from the 2 roots possible here, 2 plus 2 root 3, 4 plus 2 root 3, and 4 minus 2 root 3. Of course, this A has to be equal to this. It cannot be greater than 2. This is ruled out. This is left. So now, finally, we need area of the equilateral triangle. So side of the equilateral triangle, remember, was A square plus 4. This was equal to side square. This will give me side square is equal to Square of this, which will be 16 plus 4 into 3, 12, minus 8, 2 into 2, 16 root 3, minus 16 root 3, and finally plus 4 again, which gets me to a total of 32 minus 16 root 3. This is side square. Area of an equilateral triangle is given by root 3 by 4 side square. So side square is, let me take 16 out common, 2 minus root 3. So I get 4 here. So from here I'll get root 3 into 4, 8 root 3 minus 12, or the area of the largest equilateral triangle that can be fit inside a square of area 4 square centimeter is going to be option C, 8 root 3 minus 12. And that will be the entirety of questions for this week. Even we are coming closer, I'm increasing the number of questions so that I can do it in lesser number of videos. Hopefully you learned something. See you again next week with more geometry videos. Yeah, bye.